number between 0 to 1. I can interpret the ranges of probability in parentheses, near 0, near 1, and near 1/2.
So when we talk about our probability, probability is going to be usually anywhere from 0 to 1. That's our range. It's not going to be more than that. And a lot of times we might even think of it as going from 0% to 100%. Nick, I'll ask you to talk, okay, when I'm ready for that. But if not, I don't want to hear your voice, okay? All right. So as you are looking at this, and we fill in that next part down, it says when you perform an experiment, the possible results that we are looking at. Those possible results are actually called our outcomes. So I know it. So when you are looking at that, when we are looking at the possibility of when we do it, we call those things our outcomes. So when we talk about outcomes, it says once you specify an event, the possible, you're just going to be filling in your notes. The possible outcomes for that event are called our favorable outcomes. And the probability is what we are looking at for that next one. The probability of an event is the word you're going to put in, is measuring the likelihood that that event will occur. So when we are thinking about something, how likely it is to occur, we talk about both theoretical probability, and then the other word that we are going to be using is experimental probability. So experimental probability is when you actually do the experiment, whereas theoretical probability is what we think will happen. So then you should have had all of these. Wait, I'll ask you to comment in a few minutes, and when I do that, I'd like to hear your voice, but if not, I don't want to hear your voice. So when we think about these, so theoretical probability is when you flip a coin, you think that half the time you're either going to get heads or tails. Now, Jaden, if I want you, and Gavin, if I want you to comment, I'll ask you to. Now, if we actually do the experiment and you take a coin and you flip it 10 times, that does not mean, again, we want to get through this if you want to get your test back. So when we actually perform the experiment and flip the coin 10 times, and 3 of the times heads come up, and 7 of the times tails come up, that's my experimental probability versus theoretical. So on the top of the next page, you're going to see this number line that goes from 0 probability, where it is impossible, to 1, where it is 100% of the time it's going to happen. Okay? To when we think about something being unlikely, that's like 25% of the time. So between 0 and 25%, that's kind of unlikely. Likely to occur half the time, that's our 0.5. And something is probably pretty likely if it happens 75% or more. So each event going down here, I would like you to think where you should place that letter on our number line up here. You will see a live dinosaur on your way home from school today. You're not commenting, you're just putting that letter. I would like you to write that letter on your number line, and we are being serious. And if you want to try and be funny again, it takes us a lot longer. I know it's the end of the day, but if we are looking at that. If we were going to place that letter A, Grace, where do you think you might place it? Impossible. Right above here. It is not very likely that we are seeing a dinosaur today on our walk home from school. Okay, again, comments, you're going to save them for just a little bit. Okay? So if I look at the next one, B, a solid rock dropped in water will sink. What are we thinking, Lucas?
B is 1.
B should be at 1. You drop a rock in water, it's definitely sinking. That has a probability of 1. A coin will land with tails side up when flipped. So what I want you to do right now is I want you to place these and then just kind of check with the people sitting by you and see if you agree where they place them. Okay, place them up on this number line. So we already put A and B up here. I want you to put where you think C, D, E, F, G, H, where you think each of those would be. And you can talk to your shoulder partner quietly.
Technically,
See.
I'm gonna put it at
See at 0.5. I like that. If we're looking at it will rain tomorrow. Okay, if we're looking at that one, Gavin, what are we thinking?
0.5.
Maybe 0.5. Okay, we could put that one at D also. Now, if you knew the weather forecast and it was saying that it's a 60% chance of rain or a 10% chance of rain, then you might place it differently, right? But if we don't know, we think maybe it could be 50-50. But if we heard the weather report this morning and they said it's not supposed to rain the rest of this week, then we might place it way over here, right? Okay. As we are looking at E, Ben, where do you think you're placing E? About where? 0.5. So you roll an even number. There's half even and half odd. So again, we think E should be right at that point also. You attend the same school next year. For most of you, that's going to be what?
Likely.
Very likely. That's going to be like a 1, right?
Oh.
Unless you know you're moving. Now, could this be anywhere from 1 to maybe, in this class, maybe a 0.8, right?
0.
0.8.
0.
Yeah.
Okay?
0.
So, if you were going to attend the same school, so thinking about if you know you're going to be here, that would be over here. If you know you're transferring to a different school. Now, if I ask this question of my 8th graders, right? Almost all of them would be 0, I hope. A spinner with equal parts, numbers 1 to 4 that will randomly land on part 1. So you have a spinner, it has 4 equally divided parts, 1, 2, 3, and 4, right? Probability that it will land on the 1 should be what, Jack? Feel? 1 out of 4, 0.25, right? We think that that's kind of unlikely as we're looking at it 25% of the time. If we are looking, we have a red cube drawn randomly, selected from a bag that has 3 red and 1 blue. What do we think for that one, Kylie? We're just going to draw out one. We want to get red.
75%.
75%. Okay. So we would be looking at that letter H being over here. Okay. All right. So as we are looking at this, the next thing it asks you to do, and I would just want you to put like an arrow, and it says design a spinner. So we're going to put, when you think of a spinner, right, that has like that arrow going around. Okay. And so as you are looking at this, I want you right now, and I know you don't have colored pencils, but if I wanted to design a spinner that will give me green 100% of the time, what do I know about my spinner is that this has to be all green, right? This one says design a spinner where the probability of getting green is 0. That means we have to have maybe all, just not green, right? All yellow, all blue, all some other color. Okay, just leave yours down on your desk. There you go. Okay. The next one says design a spinner where 2 outcomes which are equally likely to land red and green. So please make sure you designate which is which. Okay? Draw this right now on your paper. If you haven't, just sit quietly. So if I was filling this in, Katie, what would I put down? If I'm looking at drawing it, what has to be the case?
You have to have 1 half be red and 1 half be green.
1 half is going to be red, half is going to be green. Does it matter which way I design that half? No, I can even have half being green this way and then putting the red on the other half. I could have divided it into fourths and done it like every other section, right? It doesn't matter as I have, so I have half of it. Nick, a question? And I want you to take that off.
In spinners, you have to put like an arrow.
No, you do not have to have that arrow on there. Okay? So the next one says, as we are looking at that next part, says, what do you think it means for an event to have a probability of a half? What does that mean? What it really means is, I want you to tell your shoulder partner, what do you think that means? If I gave you this statement and you had that question, what do you think it means for an event to have a probability of a half? And I said it should occur blank % of the time, Jack. It should occur what % of the time if I am looking at that, Jessica? 50% of the time. Half is a decimal point 5, 50% of the time. Please put that down. At the top of the next page is where we're going to look at our probability of an event, and I know some of this is going to be probably pretty easy for you as we are looking at it. So we are looking at this, it's always the number of successful outcomes to our possible outcomes. So I want you to look at those different balls where they have stars and stripes and circles on them. And it says, find the probability of randomly choosing a striped one, which there are 7. You can just count them on your own. You can count them in your head. And if we are doing this, we are looking at a total of 10. So when we write our probability, what I'm going to ask you to do is we want to keep it as a fraction always in simplest form. So in this case, I'm going to have the 7/10, or I'm going to have a decimal, which is 0.7, or I can have the 70%. And if I do not specify when we take this test, I don't care which way you put it in. If I tell you to put it as a decimal, then you want to make sure you put it that way. And if I say put it as a %, then you want it that way. But if you put it as a fraction, and you have something like 14 out of 20, I'm going to mark that wrong. 14 out of 20 is not a fraction in simplest form, and anytime you give me a fraction for your probability, it must be in simplest form. So I always want the fraction to be in simplest form if you do that. So for the rest of your mathematical career, you always want to have your fractions in simplest form. So I want you to take a look. First thing we want to take a look at is how many total marbles are we looking at in this case? So count those up as you are looking at those. So we are looking at kind of nice 10. So we know in each case here we're dividing by 10. What I would like you to do, quietly, is tell me the fraction in simplest form. Then I want you to put it as a decimal and as a percent for each one of these. Okay?
No yellow ones.
So, if you are looking up here,
No yellow ones.
if we are looking,
Orange one is yellow.
so, if we are looking, if I'm looking at green ones, I have 3 out of 10, 0.3, 30%. Schnick. If I'm looking at blue or red, that means it could be blue, which we have the 4, or it could be red. So I'm looking at 6 out of 10. I want to simplify it to 3/5. That is 0.6. That is 60% when I look at my percentages. So I want to have all 3 answers. Probability of picking that I don't pick yellow. And as we look at these, I think this is their yellow. Kind of looks orange, but it's yellow. So I have 1 yellow, right? So if it's not yellow, that means I have 9 out of 10, 0.9, 90%. Okay, so I have 3 answers that I'm always looking for. Okay? So when I look at this next one, probability of picking a black marble.
0.
There are no black marbles, right? That probability is 0. And we knew this from earlier this year, that 0 divided by any number equals 0, right? 0 divided by any number equals 0, but if you divide by 0, that's when it's the undefined, okay? So, it says, what's the probability that I pick red, blue, green, or yellow marble? Then we are looking at, we've named, and again, I'll just ask you to probably stay after with me because you can't refrain from doing that. So I'll ask you to talk when I need you to, but 10 out of 10, which is going to be the 1.0, that would be my decimal, or 100% if I am looking at that. Okay?
That's an extra.
Yeah, there's just an extra box on there.
So, on the next part with the animal training,
Trading.
please read, Zach.
Cat that knows the shake command offers one of its front paws to shake. The table shows the number of times the cat offered each of its paws when asked to shake. What is the experimental probability of the cat will offer its right paw when asked to shake?
So first thing we need to know is our total, right? Our total number of outcomes. So our total outcomes is going to be, if we add those two together, 38 plus 12 gives us 50, okay? So the first thing you always need to compute in order to find probability is you need to know the total number of outcomes. 50 is our total, and so if we are looking, and this is how we usually write our probability, we say probability, and we're going to put it in a parenthesis of the right paw. We put our back parenthesis, and then we put an equal sign. So the probability of shaking the right paw, which would be 12 out of 50, and now we want to simplify. So 12 out of 50 simplifies to 6 out of 25. Now you want to take your calculator, or if it was 50, what do I take 50 times to get 100? 2. So I'm going to take 12 times 2 and get a decimal of 0.24, right? That'd be 24%. 50 times 2 gives me 100. 12 times 2 gives me 24. That'd be 24 hundredths, 0.24. Or, for a percentage, 24%. So, if we are looking at that one, the probability that it will offer its right hand, we just put that right up here. 6/25, 0.24, or 24%. So you don't need to write it again. Key thing to remember whenever we do probability is we are looking at the word successes over the total. It is always successes over your total. Okay? So, I do not want you to put your notes away. I want you to keep them out as you are taking a look. This next part down, because we are going to go into the I2 notes. We're going to do those. So keep your homework put away. So, it says Robert tracked whether guests knocked on his door or rang the doorbell. He wrote his results in the table. What's the probability the next guest will, in this case, ring the doorbell? So, doorbell and knock. First thing we want to know is what is our total, which is
35. No, 25.
25. So, probability doorbell, we are talking about that there were 15 successful outcomes for that, right? Out of our total of 25 trials, which means our probability in simplest form is 5 goes into each, 3/5. 3/5. If we are looking at that as a decimal, should be 0.6. And as a percent, please write down 60%. So it then says, what's the probability the next guest will knock? So I want you to write it this way. Probability that they will knock. I would like you to write it first and then simplify. Okay? Do I have to put it out of 25 if I know the first one was 3/5 simplified? And that was 3/5 of the time people rang the doorbell. How many fifths should people be knocking on the door? 3 out of 5 times they ring the doorbell. If I wanted to put out of 5, it should be what? 2. The 3/5 and 2/5, they add to 100%, right? Those are my only options. You were either knocking on the door or ringing the doorbell. So, my decimal is 0.4. What do I know about these two things together? They have to add to 100%. 40% plus 60% would give us 100%. It now says, well, what if there's 150 vehicles that are purchased and 45 were SUVs? What's the probability that we will purchase an SUV? I would like you to please do that right now. If you have it done, awesome. Some of you do, some of you don't. You're going to start with probability of SUV, and then put your numbers, simplify it, give me the decimal and the percent. Jacob, you're going to start with what number in the numerator?
45.
45 over 150. We would simplify that to 3/10. Jack Tarver, what'd you have for your decimal and percentage? 0.3 and our 30%. Okay? Now, tonight you're going to be doing the homework, which is worksheet 1I1. Don't put your notes away. Selected crayons from a large bay of crayons. The table below shows the number of each color crayon in the bay. Estimate the probability of randomly selecting one crayon from the bay. So, the probability, so this is going back again to what was in our first lesson. The probability, we're going to say, of picking a blue, right? So probability, you're going to write it out this way, probability of blue. As we look at blue, we had 5 of them. Out of a total of, add yours up, we should have 30 total, okay? So we're going to have 5 out of 30. We're going to simplify that to 1/6. 1/6, some of you might remember from the beginning of the school year, is a repeating decimal, right? Comes out to be point, and if you don't have that, you might put it in your calculator, you get 0.16 repeating. So 0.16 repeating as a percent, you're going to put that as 16.6 repeating percent. So these are the 3 answers I am looking for. The next one says, what's the probability of selecting a red or yellow? So you're going to put, as you write the problem, probability of red or yellow equals. Again, we're looking out of 30. So start this one on your own. Put in the numbers as you add your red and yellow. So you're just looking at that table up above. It's right in your notes. If you don't like looking up, it's right in front of you. Caleb in the back, how many did you have? Red and yellow?
9.
9. So 9 out of 30, we're going to simplify that to 3/10. We are then putting our decimal 0.3 and our percent, which would be 30%. So which color is most likely to be selected of all of ours here? Brown. The brown, if we are looking at that. And if we are looking at brown, we would easily be able to see that that was 10 out of 30, which gives us 1/3, 0.3 repeating, 33.3%. You do want to keep the repeating line because it is not exactly 33%. It's 33 1/3, 33.3. So right now, I want you to look at this next one. So now we're kind of going back and using some of our proportions is one way of thinking about this. So 300 crayons are selected. Predict the amount that would be blue. So we knew that it was 5 out of 30. That was our blue, right? At the beginning. And we're trying to say if we would have had 300 crayons. So I'm taking 30 times what as I look at that? Times 10. And so I'm going to take 5 times 10 and I should have, my probability would be, I would think that there should be 50 blue crayons in there, okay? And all you would have to do to justify your reasoning is showing me this work, right? You're just going to show me how you got that, okay? Now, when we set up proportions before, we also said we could have cross multiplied. Remember you were doing that earlier this year when Mr. Lane was here? Okay. As we look at this one, it says seventh grade students surveyed 25 people at her school. She asked them how many hours per week they spent playing sports or games outdoor. The results of the table is this. We are asked to make a dot plot. So, if we are doing this, dot plots mean just simply that above each of these numbers, you're going to put the frequency. So at 0, we're going to put 3, right? What's our most that we have? The most is at where? 3 hours, right? That's our most. 7 people said 3 hours. But if I'm going back, at 1 there was 4 people. At 2 hours there was 5. And so I'm simply making above that number, I'm just making dots so that I can see what those were. Okay? So at 4 we had our 3. At 5 there's nothing, so you're not putting anything. Then we had 2. And we had
The one crazy kid.
1 person that was out all night, 8. So it says, suppose a student is selected at random. What's the probability that their answer is 8 hours? So how do we write that? Your answer looks like this. Probability of 8. P of 8. Okay, that means probability. So when you see this written like this, mathematically that means what's the probability of getting 8, which we would say is 1 out of 25. That's not very many. If you put it in your calculator, 25 times 4 gives you 100. That means 0.04 or 4%. So, probability that they would answer 3 or fewer hours. So 3 or fewer. So we want to add all those people that are probability of 0 to 3, right? Hours. And we are actually talking about 19 people, right, out of 25. Most of our people were outside from 0 to 3 hours, right?
They're smart.
So, again, to take 25 times 4 gives us 100. 19 times 4. What did I get net? 0.76. 76%. The last one says, okay, there's 200 people at our school. What is your estimate for the number of students that would say they play sports or games outside for 3 hours per week? So, we're thinking, first off, what's our probability of 3? It was 7 people, right, out of 25. But now we're looking out of 200. What do I take 25 times to get 200? 8 times 8. So if we have times 8, we're going to take 7 times 8. 56. And we should have 56 students. Okay? Now,
does play 3 hours a week.
that played 3 hours per week outside.
That's the wrong number.
So, as we take a look at the top of this next page, making predictions. Okay, on this next page down. It says cell phone survey had 150, 12 to 17-year-olds indicate 48 of them have a cell phone. Which equation would you use to predict the cell phone of 12 to 17-year-olds if there were 1,000? So I just want you to circle the one that you would choose and then just be ready. Circle the one that you would choose. Be ready to explain why. If we are looking at this one, make sure you have just quietly talked to your shoulder partner to see which choice you would have, if it is A, B, C, or D, and be ready to tell me why you think it is that one. Zach and Jeff, what do you got? A, B, C, or D? C. Everyone agree C? Okay. 48 to 150, that looks good. This one, probably not so much, the thousands in the wrong place. 150, that relates to our 1,000, and we'd be looking at this one correct, okay? It says that Mr. Anderson's third period math class, 5 out of 20 students missed question number 5. Predict how many of his students would miss question 5. So, in his third period, there was 20 people, right? So the probability that they miss question 5, right? Probability that you miss 5 happened to be 5 out of 20, which simplifies to 1 out of 1 out of 4, 1/4 of them, right? Do we have to simplify it if we're finding this problem with 100 students? If we have 5 out of 20 and we want to find 100? It might help you to put it at 4, but what do I just have to take 20 times to get 100?
5.
Times 5. And I should have, if I'm looking at this, 25 students. So as we are looking at that, we're going to look at 25 students, okay? Now, this last part of the notes, and that's why I wanted to get through this, because it's really not that long, and then the rest of the time you'll have to work. So it says a survey, if you are reading this, a survey of 100 households, 48%,
Talking about
48% had 2 or 3 remote controls. Predict by writing and solving an equation the number of households out of 2,500 that would have 2 or 3. So when I go to set this up, I'm going to write it this way, right? This is my probability, and we are talking about probability of 2 or 3 remotes, right? And so if I'm looking at 2 or 3, first thing I started off with was 48%. I had 48 if I wanted to think of that out of 100, right? Equals, Kylie, what should I have in my denominator? 2,500 in my denominator. This is like my x, right? That's what I'm trying to solve. Now we have a couple options. To me, the easiest one at this point is I'm looking at what do I take times 100 to get 2,500. And if I'm looking at that, I'm going to take 100 times 25, right? That gives me 2,500. So on my calculator, I'm going to take 48 times 25, and x should be equal in this case to
1,208.
1,200. Okay?
Oh, you got 200? I got
Yeah, it's 200.
I don't think you made some mistakes.
It's 1,200.
So, again, the other way you could have done that is you could take on your calculator 0.48 times 2,500, right? That's also going to give us 1,200. So 0.48 times 2,500. I would like you to look at these next two. I would like you to set them up. We're talking about the probability in this case that they are watching one certain program. America Has Talent, right? America's Got Talent. We're looking at this probability. Okay? That's our TV show because it says a certain program. We're going to say ours is America's Got Talent. So think about that, and I want you to set it up for me. We would be looking at out of 5,000, what should be in my numerator? 460. So of the 5,000 randomly selected households, 460. Can we easily simplify this? This is 46 over 500, right? We could probably simplify it more. What decimal am I talking about? Put it in your calculator. 0 point. Is it even 10%? No, comes out to be what? What do you have on your calculator? Who has a calculator? Let's put it in for us. Come to math class, make sure next year when you're in algebra, you all have a calculator with you.
It's
Divide.
0.092.
So, thank you. From now on, there's calculators in the front. Don't waste our time. Grab one. 0.92. So, what we know is this is our decimal. if we now have 105 million, right? So we are going to take this decimal. Just like here, we took 48% times 2,500. 105 million people to get our solution. Of that 105 million households, those of you that have your calculator and have plugged it in, quiz. Kylie, what'd you end up with? 9 million? 9,660,000. The next one says you surveyed 200 randomly. I would like you to do this one on your own, please, right now. Set that fraction up. I want to see a fraction, probability equal, and then I want to see how you figured that out. So do that right now. Read the question on your own. If I am setting it up, Micah, I might have started with what? 130 divided by 200. Now, if I'm looking at that, I might simplify that fraction because I want to work with smaller numbers to 13 over 20, right? And if I have 13 over 20, I am then looking at a town that has 1,500 to X. Now, I could have put 1,500 up here. I don't know if you remember when we did proportions, we said you could have cross multiplied, right? So you had 20x. And then you would have equals 13 times 1,500. You could do it that way. You could have found this to be a decimal. 13 divided by 20 comes out to be point how much? 6.5. And you could take that times 1,500. And all of these ways, with all of them, would give you that answer. So, you are working on these next couple lessons.